Okay, so now we are continue with the examples 3.6. So look at the question. So 460 volt, 25 horsepower, 60 hertz, 4 poles Y connected, 1 rotor induction motor has the following impedance in ohms per phase referred to the rotor circuit. Okay, so this is the parameter for the R1, R2, X1, X2 and also the XM. So the question is, so what is the maximum torque? Okay, so from what we have studied, so the maximum torque actually is the T max, okay, the motor, and what is the speed of the the slip dust it occurs. Okay, please remember that the first thing that we need to do actually, we need to find the voltage Thevenin. So if we can draw the Thevenin, okay, draw the equivalent circuit first. Okay, this is R1, this is X1, and then this is X2, this is R2. Okay, so this is the equivalent circuit. Okay, so this is the XM. Okay, XM, so R1, X1, X2 and also the R2. Okay, this is R2 over S. Okay, if I'm not mistaken, this is the R2 over S. Okay, this is R2 over S. Okay, so this is the voltage. So we want to find the Thevenin. Okay, from here. Okay, VTH. Okay, VTH. Okay, and also the ZTH. Okay, this is the first things that we need to do. Okay, so yeah, we know before that we already find the things, and we just use directly the formula. Okay, so where is the formula actually is the for A, VTH is equivalent to XM over power root of R1 square plus X1 plus SM square. Okay, so you also can use the formula of XM over XM plus XM, X1 plus XM times V phase. So since our calculator can, this means time V phase. Okay, since our calculator is a bit intelligent nowadays, so we can directly use this equation. Okay, so you just enter the information. So XM is 26.30 over R1 is 0.641, okay, square plus X1 is the 1.106 plus 26.3 square. Okay, this is power root. Okay, multiply with the V phase. Okay, this is a V line. So V phase, how to measure? So 460 over square root of 3. Okay, so from here we get the value of 255 255.2 volt. Okay, this is a voltage Thevenin, and we also have the ZTH. So as we know that the ZTH is equivalent to RTH plus XTH JXTH. So from the equation given, so the RTH, okay, the RTH is equivalent to R1 times xm divided by x1 plus xm square. Okay, so it is 0.641, xm is 26.3 divided by x1 is 1.106 plus 26.3 square, and this is equal to 0.590 ohm. Okay, so this is the RTH. Okay, and of course we also want to find the XTH. Okay, XTH is equivalent to x1 from the given equation. Okay, which is this one is equal 1 to 1.106 ohm. Okay, this is XTH. Okay, so now we want to find the T max. So before we want to find the T max, we need to know the value of X max. Okay, so to find the X max, okay, so since we know already the equation, so the equation is R2 over power root of RTH square plus XTH plus x2 power of 2. Okay, so this is equivalent to RTH is R2 is 0.332 0.332 over root 0.59 square plus 1.106 plus 0.464 square, and X max is equal to 0.198. Okay, so this is the X max. Okay, so before we look at the torque, so since the torque equation have the value of Nm, so the torque equation doesn't have the Nm, but consists of the omega sine. Okay, so since the question also asks the motor speed. Okay, before we go to the torque, we need to find the Nm first. Yeah, we can go find the torque, but it's okay. We go to find the speed. So the mechanical speed. Okay, the mechanical speed. This is Nm. Okay. Okay, we just use the equation. It's 1 minus s times n sin. Okay, so from here we can see that the n sin. Okay, n sin we easily can use the formula of n sin equal to 120 Fe over P. Okay, this is 120 times the frequency is 60, so number of pole is 4. Okay, from here we can get I think 1800. Okay, 60. Okay, so this is equal to 1800 rpm. Okay, so S is 1 over 0.198 times 1800 is equal to 1404 rpm. Okay, this is the speed and this is the slip, and the torque. Okay, the max torque, the max torque. Okay, or T max, the induced maximum. Okay, so T max is equal to, the equation is a bit long. Okay, so 3 times V TH square divided by 2 omega sin multiple with RTH plus power root of RTH square plus XTH plus X2 square. Okay, it's a bit long. My handwriting is not very good. It's okay. And then okay, so the T max. Okay, so we just put all information. So this is 3 times the VTH, so 205.2 square divided by 2 omega sin. So omega sin we convert the N sin is equal to so we convert from the RPM to radian per second is like this. Okay, not N sin, but the omega sin. So omega sin is equal to N sin times 2 pi divided by 60. So 1800 times 2 pi divided by 60 is equivalent to 188.5 radian per second. So we put here is 188.5 multiply with 0.590 plus power root of 0.95. Oh, this is square plus 1 point, this is also square. Okay, 1.106 plus 0.464 square. Okay, and then we get the value of 229 Newton meter of torque. Okay. Okay, then the next question, what is the starting torque of this motor? So as we know that the torque equation, okay, the torque equation is including the S. Okay, so I rewrite again the equation. Okay, okay, I rewrite again the equation. The torque is, this is for B, B. So torque induced is equivalent to 3 VTH square R2 over S divided by omega sin multiply with RTH plus R2 over S square, so this is square, plus XTH plus X2 power of 2 square. Okay, so you can see that this is included S. So as we know that from the graph, okay, from the graph we can see that this is a bit linear at first, and then go to the maximum, to the pull out, and then the starting. Okay, at this point, so this is Nm equal to 0, and this is Nm equal to N sin. Okay, so this is S equal to 0, and this one is S equal to 1. So this is the starting point. Okay, this is the starting torque. Okay, so at the starting torque, the S is equal to 1. So we just replace S into the equation and include everything the parameter. Okay, so we put everything. So VTH is equal to 2.255.2 square times with 0.332 ohm, okay, divided with omega sing is 188.5, okay, and times with RTH, which is the 0.59 plus 0.332, this one is square plus the 1.1.06 plus 0.464, okay, the square, okay, and then we will get the value of 104 Newton meter of torque, okay. Okay, now let's move on to the C question. Okay, so at this C question, they ask when the rotor resistance is double. Okay, rotor resistance is double, which is the R2. Okay, so now R2 I can say R2 prime is equal to R2 2R2. Okay, what is the speed at which the maximum torque occur? Okay, they ask the speed, so which is the Nm. So what is the new starting torque of the motor? Okay, from here what we can see here. So we already know that the equation of S max. Okay, so the value of X max over here is included the R, or you can say that the S is proportional to the R2. So when the R2 is double, so of course the S max become also double. Okay, so the value of X max before actually is 0.198. So the new one is times 2. Okay, so for C, the new X max, I can say as X max prime is equal to double of S max. So it's equal to 2 times 0.198 is equal to 0.396. Okay, so and then they ask about the speed. What is the speed? So you just use the formula, which is right, Nm prime is equal to 1 over kurungan bracket 1 over S max prime, okay, times with the N sing. So 1 minus 0.396 times 1800. So this one is equal to 1087 RPM. Okay, so then they also asked about the maximum torque. Okay, as we know before that the torque, okay, the torque induced is independent of R2. So doesn't matter when the R2 is increased, so the torque is still maintained. The torque is still maintained because it is independent. So just S, so because S is proportional to the R2. So when R2 increase, S2 follow increase. Okay, so the T max at this point, okay, still the same. So T max is equal to 229 Newton meter of torque. Still the same. However, they ask is the T. They ask is actually the starting torque. Okay, the starting torque. Okay, so we rewrite again starting torque. Okay, starting torque. Okay, so we rewrite the equation. So it is the T induced is equal to 3 VTH square R2 over S. So where S is 1 because S equal to 1 because it starting. Okay, times with the RTH plus R2 square plus XTH plus X2 square. Okay, so you can see from here the X, there is a R2 and also the S. So S equal to 1. So R2 at this point, I can say that R2 prime is equal to R2. Okay, the value of R2 is, from the equation is 0.332. So 0.332. So for the new one is 0.664 ohm. Okay, so we just replace everything. So 3 times VTH, which is the 255.2 square, times with 0.664, S is equal to 1, and then the omega sink is equal to 188.5. RTH, okay, RTH is 0.59 plus R2 0.664, X2 plus XTH is 1.106 plus X2 is 0.464, okay, square, and this is equivalent to 170 Newton meter of torque. So I really hope that all students understand and can do by own. So this is the talk at start. Okay.